Hi, we're going to discuss inverse functions. So if you have some function f of x and a point AB is a point on that graph, then the function f, it's written like this, f to the negative first power, that's what it looks like. It's called the inverse of f of x if for every point AB on the graph of f of x there is a point BA. So basically what happens is you switch the coordinates of points. Let's take a look at example 1. So it's going to be easier to understand. If the point 2, -5 is on the graph of f of x, then what point is going to be on the graph of its inverse? Well, since we switch x and y, it's going to be point -5, 2. That point is going to be on the graph of the inverse of f of x. Let's use a table of values for f of x, and we will be completing the table of values for the inverse. All you need to do is switch the x and the y coordinates. So if the point -1, 3 is on f of x, then the point 3, -1 is on the inverse. And this one is going to be 5, 0, and -1, 2, and -3, 4, and lastly it's going to be 0, 9. So far, simple, right? How do we write inverses of functions? So there's typically a 4-step process that we follow. We're going to replace f of x with y. We switch x and y coordinates. We're going to solve the resulting equation for y, and we're going to replace y with the inverse, f inverse. So how does it work here? So our first step will be y equals 3x minus 4. So that's step 1. Step 2, we switch x and y. So it's going to be x equals 3y minus 4. Our third step will be to solve this equation for y. So x plus 4 equals 3y. 3y equals x plus 4, and y equals x plus 4 over 3. And the final step, step 4, will be the inverse of f is x plus 4 over 3. The inverse of g of x equals x cubed minus 6. So the first step will be y equals x cubed minus 6. Step 2 will be switching them, so x equals y cubed minus 6. Step 3 will be solving that. That means y cubed equals x plus 6. Y equals the cube root of x plus 6. And then we're finally going to write that with the inverse function notation. G of inverse of x is the cube root of x plus 6. Do it for this one. I want you to note that there is a restriction for this function as far as what x can be. It is going to be important once we get the inverse of this function. I'm missing the name of this function. Okay, so step 1, we're going to have, I want to underline this, we'll get back to that. Y equals square root of x minus 4. 2, x equals square root of y minus 4. 3, it's going to be, we're solving that, so it's going to be x squared equals y minus 4. Y equals x squared plus 4. Step 4 is going to be the inverse of h of x is going to be x squared plus 4. This is where you need to be careful with. If x here is going to be greater than or equal to 4, that means the y of our final function is going to be greater than or equal to 4. And this is going to be important when you actually try to graph it, because there is a restriction for this one. And the restriction here is that if this is the case, then the y coordinates here are going to be from 0 and up, which means the x coordinates here are only going to be from 0 and up. If this function has to do with the range of the function, but over here, for the original function, y is going to be greater than or equal to 0, which means its inverse from that, its inverse is going to be x is greater than or equal to 0. So how do you verify that one function is the inverse of another? The process involves that you take the composition of one function of the other function and the other way around, and if both of them produce the same value of x, then the two functions are inverses, and if you don't get that, then they're not. So if we do the inverse of f of g, so it's f of g, so g goes into f, it's going to be 2 times 1/2 x minus 3 plus 6, which is going to give us 2 times 1/2 x going to give us x, 2 times negative 3 will be minus 6, and plus 6, and we got x. This is what we want. What about the other way around? G of f of x. So now g goes into, no, I'm sorry, f goes into g, right? So it's going to be 1/2 2x plus 6 minus 3. Then 1/2 times 2x is x, 1/2 times 6 is 3, minus 3. We got x also. We can say that f of x and g of x are inverses of each other. Keep in mind that if we say that one function is the inverse, like we say f is the inverse of g, then g also will be the inverse of f. They come in pairs. Alright, so here it's a little bit more challenging because we have 3 functions. We need to figure out which 2 are going to be inverses of each other. So let's try to do f of g. See what we're going to get here. So g goes into f. That means we're going to have 1/5 x plus 8. Right, we're plugging in this in here, and then minus 8 and divided by 5. The 8's cancel, but you're going to get 1/25x. That does not equal x, so it's not f and g. Could that be g and h? Right here, no. So g of h. By the way, there is no need to do g of f because you already did not get x. I'm sorry, g of h. So g goes into here. We're going to have 1/5 times 5x plus 8 plus 8. It already looks like it doesn't equal x. What about f of h? So f of h of x. So this function goes in here. We're going to get 5x plus 8 minus 8 over 5. That's going to give you 5x over 5. That gives us x. That's good. And if you do h of f of x, then you're going to get 5 times x minus 8 over 5. Doing h, so plus 8, right? Which gives us the 5's are going to cancel. It's x minus 8 plus 8, and that's going to give us x. And so it's going to be f of x and h of x. One thing you need to know about graphs of inverse functions, they have symmetry. Well, if the function and its inverse, the graphs are going to be symmetric with respect to the line y equals x. which is the identity function, and you can see these two graphs are symmetric with respect to that line, and these two graphs are symmetric with respect to that line. That's what it's going to look like. A very important feature of the graph of a function and its inverse. So using that, we should be able to sketch this. Basically what you do, you swap x and y coordinates when you try to do that, if you want to sketch the inverse. This point here is 3, -2. That means our point is going to be -2, 3. 1, 2, 2, 1. This one's -2, 5, 5, -2. And this one here is -5, 6, which is going to be 6, -5. And there in red I have the graph of the inverse of this function f of x. Remember, all you do is you swap x and y coordinates, plot new points, and connect them. Right. When is the function that we call it invertibility, which essentially means, does the function have inverse? Can this be inverted? And the function is going to have to inverse if we have what's called a one-to-one relationship, which means for every x there is only one y, and for every y there is only one x. And typically we use something called the horizontal line test, which allows you to see if the function has an inverse. In the horizontal line test, you don't want the graph of the function to cross a horizontal line more than once. If you try to do it here, imagine drawing a horizontal line anywhere, I'm only going to cross the graph of this function once. So this function has inverse. It's invertible. Well, let's take a look at the next one. How about 10? Well, you're going to start doing this with 10. You can see that you're crossing, in a lot of places you're going to cross the graph more than once with a horizontal line. So this one does not have inverse. What about this number 11? Let's take a look. I think it's pretty clear. Only one intersection point. So has inverse. How do you do it algebraically? So if you have an equation, how do you show that the function exists? Basically what you do is you follow that four-step process I explained earlier, and if you get a function, if you get a function as a result of this, then the function that you originally had has inverse, and if you don't get a function, then it does not have inverse. Let me show you, it's actually easier to understand with an example. So we're doing this one. So our first step will be to replace g with y equals x cubed plus 1. Number 2 will be x equals y cubed plus 1. 3, we solve it, it's going to be y cubed equals x minus 1, which is going to give us y equals the cube root of x minus 1. What we have here, I know that the notation is still missing, but what we have here, this is a function. For every value of x, I'm going to get 1y. And here for every value of x, I'm going to get 1y. This one is going to have one-to-one relationship. So we can finalize it, and we can write that the inverse of g is the cube root of x minus 1. And that will be our answer. What about this function, h of x? Let's go ahead and follow the same process. So y equals x squared plus 2. Step 2, x equals y squared plus 2. Step 3, y squared equals x minus 2. And y equals, and this is where you need to be careful. When you solve these types of equations, it's going to give you plus or minus square root of x minus 2. We have a problem with this. This is not a function. because for every x you're going to have to well, for every x that works here, so x is greater than or equal to 2, this function is going to have, this equation is going to generate two different values of y. This is not a function, therefore our answer inverse does not exist. So what happens is if you graph this function, you know this is a parabola, it's not going to pass the horizontal line test, so it does not have one-to-one relationship. However, one quick note about that. The function in example 11 was not, it was not 11, it was not 13, was not invertible, but you can find inverse if you restrict the domain. So if I'm going to say, well, let me make my x's greater than or equal to 0. I already followed this process. So once we get to this point, y equals plus or minus square root of x minus 2, since x here is going to be positive, that means y here in our inverse equation is also going to be positive. Remember, x and y switch, so whatever x here is, that's what y here is. So if x here is greater than or equal to 0, then y here is going to be greater than or equal to 0. And this is going to be our restriction that's going to be based on this. That means that instead of having plus or minus, you only use plus. So no negative. It means our equation is going to be y equals square root of x minus 2. And you can write that the inverse of h is going to be the square root of x minus 2. And this particular function is going to have inverse. It is important to understand this because some functions do not have inverse if you look at them, you look at the whole graph, but sometimes if you restrict the graph, and that will make this one-to-one relationship, then you're going to be able to find the inverse. And what I want to show you is essentially what we're doing is we're taking a parabola and we're doing only half of it. And when it's only half of parabola, that one is going to be invertible. Okay, so I hope this helps.